Hey, hi guys, this is Salim. Once again, welcome to my channel. So, in this video, I am going to tell you about logistic regression, guys. So, let's get started. So, before to go to logistic regression, I just want to say about linear regression, guys. So, why I'm saying linear regression, I'll just tell you later on in this video. So linear regression is defined as it is a statistical method that is used to find the relationship between two variables, that is independent and dependent variables. Right guys, so we denote linear regression by using the line equation formula, that is y equal to mx plus c, where y and x stands for independent and dependent variables. Now this is linear regression. So what actually the logistic regression defines, or else why we are shifting to logistic regression. So I'll first define the logistic regression and then I'll explain you why we are actually shifting to linear regression, guys. Okay, so logistic regression is also defined as a statistical method, but it always tries to predict the output value with the dependent variable using more than independent variables, guys. Like in linear regression, we are using line equation formula y equal to mx plus c, where we having uh, mixi, which means slope 1 and the independent variable x1, that is input variable. So similarly, if at all we have more than one independent variable, then by using that we are going to find out the dependent variable output, that is y. Similarly here in the case of logistic regression also, guys. So in logistic regression, we mainly use this regression for classification problems, guys, like to classify. So there are two categories, guys, that is binary classification and multi-class classification. So binary means we know that either ones or zeros, which means true or false, positive or negative. And multi-class is more than, I mean, the categories that belongs to a particular catalog, if at all more. Suppose if you take fruits, the fruits category having many types of I mean catalogs, like banana you can take catalog, apple you can take catalog. So if you get segregate each other, which means you're classifying, right? So under the category of fruit, you're classifying each and every type of the fruit with in different catalogs. So for that, multi-class classification is used, guys. So we actually use binary classification for most of the problems to solve. Now, guys, so I told that there is a relationship between linear and logistic regression, or why we are shifting to logistic regression actually. So in order to explain that, let me show you an example, guys. So let us consider this is a graph, guys. Now suppose you have taken a plane of both x and y axis with both positive and negative values, guys. Now the example here is, let us consider the weights of a person, guys. So on the x-axis you have plotted like 30, 40, 50 till 80, guys. So which means you are giving a condition here that if the person lies between 30 to 80, he is healthy. Suppose if the person goes beyond the 80, he is not healthy, guys. Okay, that is the condition. On y-axis we have taken 0 and 1, which means we are telling that true or false. I mean, yes or no. 0 means negative, 1 means positive, guys, here in our case. If the person lies between, I mean within the 30 to 80 range, which means he is okay, he is normal, you can say as 1. If the person is beyond, goes beyond or lies uh, beyond the x-axis, guys, like we do have here negative values, right, guys. So if at all negative values we occur, then we are not going to consider it in any planar graph. I mean depends on problem. For here in our problem we are not going to consider, that is the reason. So we are going to say no. So guys, now using linear regression, can we solve this problem, guys? I say yes, we can solve this problem. Let's see how. Suppose you are going to point, suppose on the weight of 30, using linear regression you are going to draw a best fit line. Now similarly on the weight of 40, 50, so you can take some random until 80, you can plot best fit line using linear regression, guys. Now what in case if the person having more than the weight, that is actually we have given here limit, because usually person weight will not be standard, right, guys. It will be changes, like it can maybe decreases or increases. Suppose let us consider that it has increased to 85. Now using linear regression, can we solve? Yes, we can solve, we can draw up to what, up to there is no certain limitation or condition, but here in our case we have limitation, that is we are telling that till 80 it is said to be positive, and here if at all it is crossed more than 80, we are saying that it is not going to be considered. So in this type of problems, does linear regression is going to help, guys? No. Why? Because linear regression actually predicts the continuous data set, guys. I mean, if at all there is a data, uh, let us consider our example, guys. So weights will be gradually increase 80, 85, 90, 95. By using that linear regression, you can plot, guys, without having any condition that it should not be cross 80. But here in logistic regression, it is not continuous data, guys. So it is going to define a particular limit at some point of time or at some point of threshold, like it is going to be satisfied or not. That is the main difference between linear and logistic, and why we are moving to logistic regression, guys. So logistic regression mainly it is used for more complex problems, guys. So here you have taken this example, and you can understand better the complexity of problems. To these type of problems, we are going to use logistic regression, and logistic regression is denoted by sigmoid function. So here it is a formula 1 by 1 plus exponential to the power negation sign of variable x. So this is the formula. So by using this, when you solve a logistic regression, the graph might be looks like, let me try and show you, guys. So since as I told, there might be also chances of getting negative values also. So the graph for the sigmoid will be S-shaped curved, guys. Yeah, this is, yeah. So for this problem, if you draw a graph, it will be like this. Yeah. Since I gradually increases this curve, guys, because the values are beyond the given condition. So that is the reason we are shifting to the logistic regression, guys. And the mathematics is very high behind this logistic regression. And guys, I'll come with the mathematics concept too in the upcoming videos for the linear regression as well as logistic regression, guys. For till now, in order to have a brief view or a brief understanding what logistic regression, so I think this will be enough for you. I'll just come up with some other video with mathematics too, guys. And now when come to implementation part, yeah, uh, let's see. Yeah, so I have taken a basic example, yeah, with the data set having only two columns. It will be very easy for you. Yeah, so these are the libraries, guys, we need to import. So pandas, numpy, matplot library. So these are the very common any problem when you are going to solve, these three has to be uh, import, guys. And sklearn, so as I already mentioned in my previous video, that sklearn is a library where you are going to get all the type of models from this sklearn. Yeah, guys. So this is the data set of mine. So I'm reading using pandas. Now, if you print the data set, these are the columns that it contains: year, experience, and salary. Now, as I told, every time you need to convert the data set into a data frame. So we are converting this now. So after converting, we are displaying each and every column. So since we have stored in the variable called x and y, x stand for year experience column, y stand for salary column. And now next, now we are using the logistic regression model now using the scale learn library, guys. So this is the way how you are going to use. So from a scale learn dot linear model, you are importing logistic regression method. So you're storing this method in the model variable. Now you're going to check for the fitness, guys. So I think if you go and check my previous, I mean beginning videos after the intro of ML, or in itself in the intro of ML, you can find the flow of ML where you need to do some steps. So here any problem, guys, while you are applying any model, you are going to check for the goodness of fit first of all to the given data set. Actually this is a very simple data set. So if at all there are multiple number of columns, then you are going to split like training data set and testing data set, as of we have done in linear regression. So where you have to check for the fitness. Now here we are checking the fitness for the x column and y column. So it says it's good. Don't go on this warnings, guys. This usually comes due to the packages. And next we are going to predict. So predict nothing but, guys, like if we take in linear regression, the predict will gives the coefficients of each and every value of data. under a column. So similarly here the predict will give the coefficients. Now in linear regression, we are going to predict, and later on we are going to apply the linear, linear regression model, and we are going to and predict the accuracy, guys. And we are plotting the graph, like the best fit line. Now here, when it comes to logistic regression, as I told in the example here itself, so logistic regression will be actually gives either true or false, like positive or negative, yes or no. That's it. With these two are the answers the logistic regression is going to give us, guys. Whether in zeros or ones or yes or no, that all depends upon the user how he wants to display the outcome. So I am using here confusion matrix. Confusion matrix, why? Because I want to display everything in zeros and ones. So confusion matrix will always helpful for the complex problems to be defined either in yes or no type of scenarios, guys. So for that we are going to use sklearn, but in the category of metrics. Now I'm using the confusion matrix method and passing the y and predicted. So why I am passing the y variable, because we are going to find out for the salary. Basis on salary, we are going to find the logistic regression for that. Now we have predicted, and the final the result is here it is, guys, zeros and ones. So which means um, so what here actually happened is, guys, so if you see this data, a year of experience and salary. So now I'll show you in graph, guys. So what happens is, so here, as I told in this scenario, we are plotting all the points, and which goes beyond or the given condition, even though we are going to plot, but at particular limit it will be stops, right? So what happens here, logistic regression will segregates all those, like suppose here we told that till 80 it is healthy, or beyond 80 it is unhealthy. So what are the points that are lies still healthy? All those are uh, going to be classified as, because logistic regression is used for classification itself. So like let us consider here. So these are all the points which actually lies beyond and below. Now suppose if I plot a line that gradually linearly segregates or differs with these 2 points. Consider only this line, guys. It's better if I erase this curve. You will understand better. So yeah, now let just consider this line, guys. So which gradually segregates the points. So these points which are lie below the given limit. Let's say we have given from 0 to and 1. Now these are the points which lie above the limit. Now logistic regression finally will give in the answer of zeros and ones, as we have given here 0 and 1. So it will give all the points which are lie here are ones, all the points which are beyond are zeros. So that is what it shows, guys, the output here, zeros and ones. So for this given data, if we plot line, and if the logistic regression segregates, these are the yes or no types of scenarios that are having, like having the relationship between the salary and years of experience. If a line is plotted, so these are the salaries that are lie with respect to the years of experience, and these are the points that are lie with respect to the years of experience, like above side and below side, guys. So this is what actually it looks. And if we predict, it is 0.133, it is nearly 13.33 percentage, I think so. Which means it's not a very good, it has to be more than this. So for that, you are going to use some other data, because for this data set, this is the accuracy that we have get. Actually it should be very more, in the sense greater than 50, like 60 and 70, it will be considered to be as a good accuracy. So since this is data that is prepared by me, so some random values I have given, and I just showed to you how actually logistic regression works. And guys, so I know this logistic regression a bit confused, uh, so I'll come up with the other video, guys, which will be very clear to you. I'm going to explain the mathematics behind, because there is more mathematics, so it will be very helpful for you to understand the logistic regression. So this is all, guys, about logistic regression. I hope you all understand this, and please do like, share, comment, and don't forget to subscribe, guys.